we've returned. I think we could say two things. One, we could try a different operating system, build, because perhaps that one's non-standard. We'll go back to 18, whatever. Uh, Despite the fact that we know that this is a current and up-to-date operating system, let's try it. We can always fail harder. Uh, so here we are. We've not done anything. So in what version of operating system are we using here? Well, scroll back up. We can try it in Debian Bullseye. File. Scroll back up. Ubuntu. We'll go ahead and comment this out. Do that. But here we are. Config.vm.box equal paste save. So exit, destroy it and bring it back up. Stark contrast to some people. As soon as I finish the coffee, we're switching to beer. Almost instantaneously. Yeah. Beer and cookie. Cookie is good. I forgot I said I wouldn't eat on stream. I'm bad at life. A terrible influence. Okay. There's kind of stalled here. No resolver. What? This makes no sense. Let's try that again. The Ubuntu we used just worked just fine. However, it was built by someone else. This one we may need to use one of our tricks from above. Previous host to configure. It should rely on the next hop upstream to do the DNS by default, but or the DHCP allocation should have valid DNS. I can only presume it's failing on DNS again. Yes. We had to go so far as to okay. We shall do this. Before we do that, we'll do this. That should work. Cut to the chase on this. So using Debian, rather than some shitty port called Ubuntu. It's running the installer. Which is here, SSF, output to a file, chmodded, and then run interactively, or non-interactively with the -y. And for some reason, it just killed itself. This makes 0 sense. It is par for the course today. So run installer. Not to worry, the cookie's almost gone. Put that cookie down. So Debian won't even install it. And we were using Boxmatic's Ubuntu before. Ubuntu Jammy 64 seems to be about the most current box here. 493 days ago. It's 2004 10 2. 2024 8 21. 2023 8 6 7. Bionic. Let's presume this fails again. And we shall save. Installing Rusty kills it. Let's do this with Jammy 64. So it appeared changing operating systems did have an impact on that one. Don't understand why. Debian did not like that at all. I suppose we also don't need this here. Okay. Ah, linker CC not found. So let's see. We find CC. We find GCC. Oh wait, we're locally. Vagrant. SSH. Okay, so yes, we don't have anything installed. So really we need to change this to apt get install y build dependencies DEPENDENCIES. So let's make sure that works. Get apt install y build DEPENDENCIES. Right, control A, sudo group apt group install y build dependencies. Group hyphen install sudo apt get group Rust build dependencies apt Ubuntu. Build essential, damn it. Yeah, that'll help. Asking for the right thing. I could combine those to one line to make them more logical, but exit. We're not in the mood to be logical. We're being contrite. Really, this goes here. This is install Rust requirements prior to installing Rust. I mean, that's kind of what requirements means. Save that. Okay. Data loading the installer. Now we're cooking. Okay. Mazel tov, we got it. Okay. Enjoy your grocery shopping experience. Yeah, that's why there's so many boxes. If you don't like one, build your own or use somebody else's. Though I will admit I try to stick with the mainline distribution build, so to speak. Well, no, it's neither. But the official Ubuntu builds by these folks. So by the Ubuntu group itself. HashiCorp has its own build of stuff. In this case, HashiCorp has one that has Chef Puppet pre-installed, which would be tremendous if that's what we were looking for, but we're not. So we now have our installation working, our tests running. Well, no tests, but our code running successfully. We're not having it chmod. It is an executable. If we run file against it, SSH. If we run file against it, we should get elf file. Oh, let's restart cd / vagrant projects. Hello. If we run file against main, we should get an elf file, elf 64-bit executable. Lovely. So it's doing what it's supposed to do. Spoda boys, spoda. So now that we have successfully done what we're supposed to do in the manual, we can return to. And yes, I did use my phone a friend. I was like, "Hey, gosh, what am I doing wrong?" And he's like, "I'm at the supermarket. Leave me alone." Yeah. So yes. So we did our install Hello World. We did our install. We did Hello World. Reviewing it, similar to C, we're using a main function, and it is all encompassing of the code that we are trying to run. And then the next thing we do is we call the print line. I guess that's what that stands for. Call our print line with an exclamation. Why an exclamation? Because it is a macro. Otherwise, it would be a function print line without the bang. So it calls the macro print line with the value hello world and the semicolon to terminate the line. Very C-like. Rust macros generate code to extend Rust syntax. And that's not encountered until chapter 20. So for now, bang is macro instead of function. And macros don't follow the same rules as functions. That's all you need to know. Let's see. Second, you will see the hello world string. Yep. Passion of the string is the argument to println the print line macro, and the string is printed to the screen. Finally, a semicolon. Yep, we get that. We compiled it and executed it. This is similar to GCC or CLang. Duh. So on macOS PowerShell, you can and yeah. So the other thing we could do is XXD main, and we see it's actually a listing. It's got a listing here. There is quite a, so if we run strings main, we get a variety of things that make sense that we would expect to see. Obviously, this macro is called somewhere in this mess, and anyway, all things do main. 3,000 some odd bytes of main. Gosh, it's an awful lot for a hello world, but here we are. This is supposed to be memory safe. So macOS, no, yeah, mostly 2 files. Under LS, main and main RS, there's no PDB. No, that's on Windows. At any rate, yeah. Hello world output to terminal. So it says as you grow, you'll want to use Cargo, the build system package manager. Cargo does a lot of things: build code, download code libraries, and build libraries. Also called dependencies. So simple Rust programs. Hello world Cargo. Don't use Cargo part that handles building code. Blah blah blah. Add dependencies. Blah blah. Don't care. Cargo version, cool, yeah, I'm sure we have Cargo. Yeah, it's there. So we could, in theory, also follow along and do okay. Create a new project using Cargo and run. That's what this is. Config. Yeah. Shell privileged. Shell, and then we want our echo Fubi, Barbie, Baspi, Fubidi. And this one's going to be CD Vagrant Projects. Because the presumption is Cargo, new, hello Cargo. Let's see this. First initializes it, and then creates the directory of the same name. Go to hello cargo. There will be a toml and a source directory. Great. So really, I don't need this file. Delete. Trash. Okay, so main. Delete. Trash. So cool. Now we are ready for our next pull. Oh, what the hell? It also initialized a new Git repository and a Git ignore file? That's fancy. Oh, you can force it to be Git. That's neat. Cool. Tom's obvious minimal language format. Cargo's configuration format. TOML. Package. Next 3 lines of configuration about it. Last line dependencies. Oh, cool. Cargo generates a hello world program. Okay. And then we do cargo build. We should compile. And then we should be able to run, target, debug, hello cargo. We could also do cargo run. Cargo check. Really, we could do cargo check. Logistically, it would make more sense for us to do it this way. Cargo check, cargo build, then cargo run. Cool. We learned new build, run, and check. Build it for release, when your project finally ready for release, release with optimizations. So it's executable target release, set target debug. Okay, I'll bite. Because we'll run strings against it, and it might be smaller. Build dash release. Cargo build. Whack dash release. Strings slash. Well, let's do this. Du h dot slash target debug hello cargo, and then after we build it, du h dot slash target debug hello cargo, and then we could do strings strings. Diff. Okay. Strings. Release. Release. Strings. Target. Strings target. Release. Hello. Cargo. I'm going to pump that out to release. See, string, Mr. Strings target. Release. Debug. Hello, cargo, debug, string, diff, release, stir, debug, stir. And then we could probably do, that should be enough. Let's go ahead and run that. Wow. You're telling me diff isn't installed? RE. Oh. Okay, great. Oh, exit. There we go. Let's run that. Okay. I'll be here.
Thank you.
Enjoy. Okay. Why did we fail? Where did we fail? Oh my. Oh shit. Of course. That makes sense. Let's try it one more time. That way we'll have this to copy and paste. We won't actually run it. Release version or debug size follows. Okay, release size follows. We have infuriated the mirrors at this point. They're pushing back. Okay, where did that blow up? So are we...
Thank you.
Nothing's moved. I would have bit them. I gotta debug file size files. So I could debug hello. Slash target debug release hello cargo. Yes, Rust. It tells us the Rust version linker that we use. GC. There's a lot of garbage that's left in these files, even in the release version. Rusty version linker GCC LD. CRTstuff.c? What the fuck? How do you trust any of this shit? Does stuff is not in here, but awful close. Right? CRT stuff. And we aren't using a cathode tube anywhere in this process. Using an LCD. My first thought is this is awful bloated for being. What else is in here? Right character. Arguments. Panic. Downwind. Mismatch fail. Implied. Copy from slice. Implied. Mismatch fail. Okay, so these must be their catches that they place into all these files that make it so safe. I don't get it. Okay. CRT stuff. Let's see. It's frame end. So there's your start. Main. And then somewhere in here there should be your data. Row data, T data. So data, BSS. Okay, so yeah, it does operate like we expect it to. It's not anything different than a C program. However, it costs more. Wait, no, it's free. Yeah. In looking at this, I'm very shocked. Don't save anything I changed. However, I want to presume this ran successfully. No, it crashed. I presume strings. Well, we've played enough with strings. Let's save and let's run that again. One more time. Let's see if we can get to where we need to be. Which is, they check it, they build it, they run it. We identify the size of it. we're installing the app again, or the installing Rust. And this is probably enough to make the previous version of the box we used work correctly. I should hope so. Oh, release. That helps. I don't care, I'm doing it again until it's right. Even if I can't spell. Well, I can't type. I probably both can't spell or type. So that's how you spend 9 minutes to find out you mistyped a letter. I'm like, couldn't you have slowed down? And I'm like, yes, in one instance you could have slowed down, read everything again and again and again, and been successful. However, you just run it and presume it's going to work. Well, that concludes that beer. The time it takes to finish a beer, I've solved my problems. And provided a more robust means by which to deploy this stuff. Oh my. Yes. Okay, there we go. Holy shnikes, we go from 3.8 megs to 428 kilobytes. Or, yeah, kilobytes of bullshit to run this app. 3.8 megs for hello fucking world. It's memory safe. We're sending that. Yeah, we have to send that because that was rather amusing. Oh yes. Upload file. Desktop. 72 kilobytes. Smartphone photo. This is megabytes. Margaret Hamilton wrote a pile of code taller than she was. Well, at least we know you should definitely be using the release, not the debugs, if you want to save any memory and space at all. At any rate, building for release, build release, target release instead of target debug. Code runs faster because it's like a quarter of the size, an eighth of the size. Turning them on lengthens the time it takes for optimizations make your rest code faster, but turning them on lengthens the time it takes for program to compile. Fine. If you're benchmarking code's running time, run cargo build release and benchmark with the executable in target release. So we can use wall. We can do that with wall, and then we can do. We can do it with just the execute. Wall. And wall. I could have just run provision, but I just find it much more fun to run the entire stack in this instance. Alright, every 20 minutes look around. Make sure you can focus your eyes still elsewhere. Ideally into the distance. I can see a marathon station from here. How cool is that? So now I know that this will work on your machine as well if you are so keen as to have Vagrant configured locally and VirtualBox started. Wow. Download installer, get components. It's funny that it would invisibly fail the linker. I still find something to be not right there. Why does it not? Okay, wall didn't quite do what I wanted it to do, but probably because we're running it non-interactively. Vagrant, SSH, CD Vagrant, projects, hello world, hello cargo, wall, target, release, hello. Okay, time. Time, target, release, hello, cargo. Versus debug. Yeah, I should have used time. Debug. Oh, that's a hell of a difference. There was a measurable difference. Yeah, we should not have used wall, but time. Release. Debug time follows, debug size follows. Excellent. I guess we don't need to imply follows. Or we don't need to say follows. That's implied. Exit, vagrant, provision. Let's see if it provisions nicely for us. It says, hey, we've already got this done. Could likely do it if not. Three 3.8 meg in half a second. Unoptimized plus debug targets in 0.18. Debug time. Hello world. Threes all across 3 seconds versus 3 seconds. Not a wow. So maybe we could add more precision, vagrant, SSH. Maybe we could add more precision to the command.
I'm like, they do the voluntary too. Oh, you stay ready for voluntary. Yeah, but that's what I'm like, or I might run it, we'll see. Yeah, it's a fun one too, you know? You don't have to like go out and everything. No, exactly. I've been cousins and so I was like, okay, I might just run it with them and chill.
1003 format. Dash V. Vagrant projects. Hello world. Hello cargo. Target debug. Hello cargo. Maybe we can only do one. I don't get it. Okay. All over the place. Okay, fine. Alright. Alright. Because it's such a negligible difference in in running time. Sorry, compile. In running time, I'm going to say it's essentially a dead heat at this stage of the development process. There is a negligible, at best, time if we reproduce the results that it takes to build that it takes to run the code between the two variants. I'm sure that as we deviate greater from the minimal complexity of Hello Cargo, we would notice a better time. However, that being said, we now have the framework within which we need to operate. So, build release. Okay. Cargo doesn't provide a lot of value for some projects. It'd be worth it as it gets become more intricate. As soon as you start needing dependencies, it's easier to let cargo coordinate. Okay, that's great. Yeah, cargo build. Great. We did all this. Woo! So source main RS. Okay. Cargo check, cargo build, cargo run. Cargo build. Cargo run. See if that works. Release. Okay, that's a valid thing. So exit. Let's do vagrant provision one last time. That should get us a little bit closer to where we want to be. It's now 3 o'clock. We've already got to our guessing game. Okay. Yeah, we ran the release. So we have our code structure ready to edit. Okay, we're going to experiment with user input. Process input, check that input is expected format. So main, we now do this. So we say source main. Okay, guess the number, input your guess. Let mutex of guess equal string. Mutable perhaps. Let mutable guess equal string dot new or string colon new. Okay, all right. IO standard in. IO dot standard in. Reline dot reline and guess. I guess you have to say the type before the. Okay, I see what they're doing. Expect failed print line. You guessed. Guess. So. We don't have anything doing a random number. Whatever. Echo 42 into Echo 42 into Echo 42 into cargo run. That, but Echo 42. Configure provision. So we're done. We got that going on right now. We're done with this one. It's 2:59. East Coast. Okay. Oh shit. I messed that up. Actually, I can all of hello cargo and generate it. However, guessing game, we used the ability control A, control V, control S. Let's run this again. This is why Vagrant. Yes, I know it would be faster to run this locally and to only run the commands that we need. However, this is giving us a process by which, hey, we're reading input, we're passing output. Oh yeah, we can't hard link because you're using an rsynced file system, so it's whatever. At any rate, it did what I wanted. It's working. So, center lib. If you want to use what isn't in the prelude, you have to in the prelude. You have to bring that type and scope exactly with a. Yeah. Under prelude. Yeah. Anyway. You have to bring that type and scope explicitly with the use statement using the standard I/O library provides you with another use of features including the ability to accept user input. There you go. So, as we saw in chapter 1, the main function is the entry point of the program. Function main, open paren, close paren. Or function main, null parenthetically, and open brace, curly bracket. The function syntax declares the function, parentheses, indicate there are no parameters, yes, with the signal. There's no semicolon there. Use semicolon. And the curly bracket blah 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 starts a new. Starts the body of the function. Okay. Yep. Print run is macro that prints from the screen. Guess number. We take the user's input. We echo it to string to the screen. Pretty standard. As you can see, we used our friend the Linux pipe command to redirect input and print it in a predictable fashion to our application. So it does, in fact, get 42. We echoed it into run. Release, and we also did it. There, cargo run. Of course, it said error destination already exists because we did that. Cargo init to initialize, and it said, hey, we can't do that because you already exist. It goes on to compile it, and things work as we would expect. So we could essentially say everything other than source we could take out here and the cargo.toml, and it would work effectively, which means we need to have a get ignore that says cargo.lock. It omits the target. And keeps source. We could go a little bit further and say, well, obviously we don't want a cargo lock kept locally in our build. And we would define that in our Rust directory would be our other get ignore file. And within that get ignore, we'd also say, hey, we don't want any .vagrant stuff because that's not relevant to what we're doing. So this is kind of fun. We've gone a little bit further than chapter 1. We made it to chapter 2. It's 3:06. We're at the top of the hour. I'm going to go ahead and stop live streaming. Maybe. So we call our print len macro with the value, and then we create a variable let mutable, which means we can change it. Guess equal string parenthetically no, which initializes a mutable guess. Let apples equal 5. So that's immutable by default, so you can't say we have more apples or more bananas. Yes, we could say we could have more bananas. We could change the value of bananas within the space, within the runtime of the program. However, the compiler would not let you do that with apples, is the presumption. So let mute guess will introduce a mutable variable called guess. The equal sign tells Rust we want to bind something to the variable now. So equals is bind. I would presume double equals is assignment. Okay, string new, which is growable. Okay. The call syntax indicates that new is an associated function of the string type. Associated function is a function that is implemented on a type, in this case string. This new function creates a new empty string function. Many times because it's a common name for a function that makes a new value of some kind. So that must be the memory safe way that the compiler, rather than linker, is identifying these things. That's really neat. Not really. It's kind of. It seems like it sits on top of C and tries to force you to do things in a very C-like but safe manner that you could probably achieve the same without too many difficulties within C itself if you were to import some other libraries and use those libraries in combination. Yeah, I kind of see where they're going. You really kind of want to have these in place of linker before linker runs, and then by the time it hits the compiler, it should all make sense. At least to the low levels. So the let mute guess string new is created a variable that is currently bound to a new instance of string. So instead of a pointer, we have a new empty instance of a string. So I wonder if there's a way to get Rust to output the linker output. Oh, wow. Interesting. So yes, you can. You can output the linker as well as the linker flags. Interesting. So, recall what we had used included the input. Call standard in function from the IO module, which will allow us to use for input. IO : did end. Parenthetically null. Did the new line in 5 spaces, I presume, for 1, 2, 3, 4. That's 4 spaces. Dot read underscore line. Parenthetically ampersand mute. Guess. So. Let's go back to our code listing. The only thing that makes sense is that they're forcing us to call wow. Okay. Alright, that's a different way of thinking. That's fine. You guessed guess. Good. Print line, you guessed, and then parentheses. Or then in curly braces, the word guess. Curly braces. Okay. Still use the function by call. Okay. Well, that's fascinating. I don't know if this is of much value to you folks, but I hope you enjoyed. I'm going to stop live streaming for now and pick this up at another time. Thank you very much for following. Enjoy the rest of your day.